All right, time for another draftphysics.com, debatephysics.com also. But, yeah, there's just no rational conversation can be had on the subject of physics. It really is like we're arguing religion. They're all just fanatics. And, yeah, unfortunately. And I guess there's no scientists here. It's just, this is somehow the theory that it's a push-averse is just too strange. People just can't grasp the concept. Just so bad. Anyway, this is the other simulation. Now, it runs in HTML, which is really nice. And it has lots of interesting features. I can make them hollow, and so you can see that the bits change color and whatnot. And again, we're at the stage where when they collide and form neutrons, or whatever, electron proton pairs, whatever you want to call that, um, that's this point we're at, and it's a little messed up. So that part has to be fixed. But you can change the speed, do lots of different things, and increase the amount of force and the radius of the bits, and the matter probably could be a little smaller. Oh, the number. Yeah, we can change the number. Anyway, so as you can see, I think, yeah, it's working pretty good. Looks like it's capturing it. So it just needs a little tweaking. Unfortunately, the guy who has spent years really on this, and his life's tough and all that kind of crap, and he just hasn't been able to devote much time to it lately. And so things are a little bit stalled, but we'll see what happens in the future and whatnot. So anyway, but yeah, so the system works quite well. Let's just make new matter. There's some new ones. So it's nice to have it, slow it down a bit, and then you can see what's happening more and blah blah blah. So there's probably what I should do is run this and videotape it, and videotape the interesting bits. So before they used to just bang into each other and stick, and so that older version is one I probably should play some of that, as it works a little better actually, because this is not. The color change is messed up on the neutrons, and so they're not functioning quite right. But anyway, eventually, I mean, unfortunately, I mean, I know some JavaScript, I know some code, but I can't really follow along on this stuff. So it's it's one of those learning curve things. I just don't want to take the time. It's going to take some time to know what the hell I'm doing, and I just don't have the energy to acquire the knowledge. But anyway, all right. So I guess I'll reference an Ian Gosling video, but what's the point? I mean, it's just ridiculously bad. They just get worse and worse. All right, so I'll go find that. All right, I appear to have found it. All right, so he took 10 days off, and so he comes back with an experiment where there's just no. It's just such garbage. I mean, there's nothing. Oh shit! Whatever the fuck all that was. So he's dropping the weights. All right. So as I pointed out, into an unknown foam substance. So he's penetrating an unknown foam substance by dropping a weight on a washer on a nail, and measuring, not even by measuring, like he could put marks on the nail and we could see how far it goes in, but instead we're supposed to read this slop. You know, and if you just take stills from it, you can see that it's obviously crooked, and so there's a ton of parallax here. It's just all over the place. It's just terrible. Just complete garbage as a video, in terms of any kind of exact measurement. You know, if you look from the bottom up, these two numbers will look different. So if you look at that image, right? Can you see that? Yeah, you can almost see that from little orange line to this washer. And then if you look at the somewhere in here, it's going to be the other one. Yeah. What the hell do you do with it? That was the heavy one, was supposed to be there. Yeah, that one's crooked, obviously. But anyway, so we have there's no facts here. We don't know anything about this foam. You know, so you can see a gigantic amount of space there. So, so what does that mean? You know, well, what are we supposed to deduce from this? So the top looks like the same, but the bottom doesn't look like the same at all. You know, from this orange line up is twice the distance. So it's not telling you anything useful at all. All right. Yeah, it's junk. So, by his theory, he knocked this one further, because this is the lighter object. But whatever. So I just go over it one more time, since and it's just they take no responsibility for any part of their obligation. So clearly there's an experiment that completely is in conflict with what they're proposing, and that's the balance. So using a balance, okay, the balance says something very different. Let's just do it this way, just for the sake of making it clear. So here's the center. So the balance clearly states, okay, that a 4 mass, okay, one distance. All right, so I have to make this a little bigger over here. All right. So here's the center line. Is the same as a 1 mass 4 distances. Okay, so that's 4 times the velocity. So a 4 mass moving 1 velocity is the same as a 1 mass moving 4 velocity. His contention is that this only needs to go twice the velocity to equal this. Now, obviously, if we put the 1 mass here, it will fail dismally on the balance to be equal. Okay, this will not equal this. So a 1 mass 2 distances will not equal a 4 mass 1 distance. So the lever's clearly saying these two things are not equal. So a 1 mass, okay, at 2 velocity does not, okay, equal a 4 mass at 1 velocity. Clearly the balance says that's not equal. So he's trying to prove, okay, by acquiring twice the velocity through gravity, all right, that somehow a 1 mass going twice the velocity does equal the same force, okay, as a 4 mass 1 velocity. All right, that's what he's saying he is proving, okay, and he keeps calling these garbage experiments evidence. So obviously foam is a bunch of little, you could even understand it as a bunch of little pieces of wood, little layers of wood. And so we've already seen the karate guys, they'll break through a bunch of cinder blocks. It's not because they're using more energy, it's because they're applying the energy more quickly. So you can fracture some surfaces and create more penetration because you fractured the surface. That is, that you're putting the energy in faster than it can take it, and it breaks like a piece of glass. So hardly proof of anything. And again, his obligation is to explain why is the lever, why does the balance, why is it lying? Why is it, how is it deceiving us? So if you have any confidence that balances are legitimate devices and they really are comparing two things that are equal amounts of force, equal amounts of energy have to be on both sides. Clearly the balance says one mass, two velocity, not equal to a four mass at one velocity. So why is it lying? How is it lying? What's the trick? Okay, where's the, how is it possible that there's, from your theory, twice as much energy on one side as the other side? Yet the balance doesn't show you there's twice as much energy on the one side as the other side. It's not there. Alright, so they won't deal with that argument, and instead just keep doing this crap where they do these less and less precise experiments that are garbage. I mean, it's just incredible garbage. Anyway, I mean, I can't even, who knows how variable his outcomes were based on what part of the foam he's going through. And how much the thing is bending, it's not even going into the surface straight. It's just pathetic that he's calling this good enough evidence. This garbage. Somebody fireworking somewhere. I don't think it's the 4th of July yet. Anyway, so I'll see if there's anything else. Alright, back. The comments have been useless, so I have nothing, I have no response. I mean, it's just one guy's going on about his insistence that somehow we all have to believe that energy turns into matter, and he proves it with nothing. There's just absolutely no reason why we have to believe that. And it doesn't help in a physics theory at all, so it's obviously some sort of religious thing for him. And so just a waste of my time. And the rest is just the typical snarky crap. Just insults. Anyway. Alright, so I'm working on the gravity page. But there's not much to say. Because this is, again, another subject where you say they don't care to examine the possibility. So, I mean, the truth is, the sage gravity, particle gravity, they call that mock gravity now. Okay. And they actually use it to teach bent space. So, Leonard Susskind uses the mechanical theory of particles, water, as a way of creating the convergence, and basically creates a push gravity. Now he has it's just a well where the water goes into a well and the water comes from a waterfall. That is an infinite waterfall and an infinite well, and so it's just as silly, as bent space. And all bent space does is provide this easy, it's a theory that doesn't have to be accountable because it's not a real force. So it doesn't have problems like drag or this or that. You can't find a physical flaw because it's not a physical function, but it's supposed to be physics, and that's the joke. So in one of Richard Feynman's lectures, he basically concedes Lesage gravity works to explain gravity. It fails in the sense that if you assume it's the mechanism to be part of the real universe, it means it has implications that we don't see, that is drag. Now, the irony is that we do see drag. So electrons and protons especially, we see lots of drag. So like, say if a sun supernovas, you'd expect that a bunch of electrons and protons would fly off, they would go through space, and they would hit Earth. They don't. Okay, so satellites, no matter where we put something out into space, it doesn't get hit by electrons and protons. Okay, so somehow all of those electrons and protons, like coming off of radioactive stuff, they all run out of energy. They all lose their energy. So drag looks like it is a real thing, and the question to ask is, how does matter overcome the drag? The trick is that ends up going back to the charge paper. Okay, so I mean, I could just draw. I mean, and then you have to look up all this stuff to find out where they got their deductions from. Because they deduce things, and you're saying, well, where did they get that from? Why did they draw that conclusion? So clearly, we can't make electron guns in the sense of a true electron gun. We have to have an electrical potential to keep pushing the electrons, and as soon as the electrical potential is gone, the electrons stop. So they need to be pushed incessantly. They just don't keep going, is the point. They do lose their energy. But what about neutrons? And clearly in the chain reaction of a nuclear bomb, the neutrons are playing the key role. But no one ever talks about neutrons maybe leaving a radioactive isotope. And the question is whether they're detectable because they don't have a net charge. I'd say they'd still be pretty detectable, but they're pretty damn heavy. But anyway, so I'm just not sure if neutrons are dragged. But the point would be is that if you did look at a neutron, okay, the simple idea of a neutron, based on my theory, you can sort of understand how it might be possible that something could keep moving. All right, so let's line that up. All right, so if you had an electron and a proton, right, next to each other, stuck to each other even, all right, and say the electron had some energy pushing it, so it has little greens on it pushing it. If I hit the proton so the proton's now moving into the field. The electron's pushing the proton, essentially. And so the proton's going to hit more force. Well, if it hits a green force, it's not going to make any difference, right? But the green force will go into the proton, turn green, do nothing to the electron. Turn red, I'm sorry. Turn into a proton force, do nothing to the electron, and just keep going out this way. So it'll be completely invisible. So all the green force won't mean anything. And a red force, the trick would be, is it can't reflect because there's no energy directly pushing the proton. The electron is pushing the proton. So there's nothing to reflect. So you could sort of understand that there's no way for this piece of proton energy to cause a reflection here. It can't make the reflection of the force pushing the electron because it's a red force. It's not a red, they're not the same. So the argument could be is that it just reflects the force, and this doesn't slow down because none of these bounce off. Because there technically isn't, you need a green to hit this electron to change how many force bits are going this way. So to do the exchanging, they have to be the same color. So you can understand that just a proton, given momentum, could maintain its velocity because opposing force would be somewhat inert. And the only thing that could disrupt that would be to cause a distance, a separation between the electron and the proton. And that's probably what happens, is they're turned and then they separate because they're turning and the force is still pushing in one direction, and so it becomes imbalanced and then force is released. Something like that. But it's clear that you can make it's clear it's open to an explanation for why complex matter, a wrench, can be thrown in space and it keeps going, and an electron or a proton, you throw it in space and it doesn't keep going. And that simple charge explanation provides an explanation for why those two things might be different. Yeah. So, but they never thought about any of this stuff because they never thought about the other video I want to make, which is one on the subject of it's a push averse. Okay. And I mean, all I can say is yeah, there's no elemental construction for a pull. And so you're almost saying, why didn't Aristotle say this? Why wasn't this already said a long time ago that, well, yes, if you're to contemplate the two concepts of push and pull, clearly push is really easy to understand, really easy to model, really easy to conceptualize, something banging into something and sharing its momentum. But a pull, there's no way to conceive it. There's no way to model it. There's no way to do it without installing some kind of magic, non-physical interaction, some sort of nonsense. And clearly physics has a nonsense particle, the gluon, where you throw it and it sticks to an object and makes it go in the opposite direction for no reason. So it's just really is a gremlin particle. It's just magic. So anyway, but yeah, besides saying that, what else is there to say about push averse? But it just leads to everything else, because once you say to yourself, yes, I have to concede that it seems like the universe probably is bumping particles. Now, they've said that before, but they usually say it in some sort of mocking way. But I mean, the idea that's so easy, and then the idea just becomes, well, it's a push universe, and I can push even amounts, or I can have uneven amounts of push, right? When I have uneven amounts of push, then things move. But when it's even, they don't move. Move, don't move. And so it just becomes understanding the balance between forces and recognizing that that's all you're interfering with is some percentage of the force that's in something or hitting something, and you're changing a little bit of the balance, and that's causing it to move. I mean, for most of the things we see, we only change a tiny bit of its balance because it doesn't move very fast. Certainly nowhere near the speed of the force. All right. So what else? I mean, push explains gravity. So many things. It's just so obviously push is the physical reality, and pulls are optical illusion. I mean, they're just it was just another way of saying attraction, when attraction really was never attraction. It was the absence of repulsion. So it's again, it's just this absence of the negative kind of thing is a positive. So not being whipped is a good thing, even though it's just removing a bad. It's not a real true good. And the same idea exists here. Push is the real thing, and you're always just looking for, when there's an attraction, you're just looking for where the push was removed that's causing the other push to have more power. So it's just balancing pushes. I mean, it seems trivial to have to explain all the obvious things, like you don't pull on a doorknob, you push on the back of the doorknob. You don't pull on a rope, you push on the fibers of the rope. It's all a push universe. It just seems strange that this would only occur to me to be important or something should be talked about, or just the very fact that there really isn't an elemental pull. I mean, that should be a big fact in physics. It's almost like the speed of force thing. It should have occurred to somebody else that, oh, come on, we shouldn't be calling this the speed of light. It should be called the speed of force. Because all the things we understand to be forces are moving this speed. And it's a little silly to say, gravity is bent space when it's moving the same speed as a photon. I mean, come on. Was it some kind of bizarre coincidence that the bent space, has an elemental velocity function that's exactly the same as a pushing force of substance moving? I mean, isn't that a little bit too much of a coincidence? I don't know. There's just no talking to you people. You're just, I don't know. People are just so goddamn belligerently stupid. I mean, they don't even want to hear a good idea. They just want to pet their garbage. They're just sitting there in their, just hugging their bathwater. They just have no clue how dumb they really are, and how I mean, they're stupid in a really kind of shitty way. I mean, they're shitty stupid. They're stupid not like ignorant. They're stupid like, they enjoy it. They enjoy being dumb. I don't know. It's a fetish or something. All right. I don't know. Fucking the truth. I mean, that's what they, they like to fuck the truth. Shit. The sacred truth. Anyway, so enough of the video. So yeah, there really is just nothing. People are just not on the subject. They can't find the subject. They can't find a relevant point to make. It's just so bad. So until I can get somebody else interested. Now, I would think that Wolfram guy, right? I mean, alright, well, let me pause and I'll put the simulation back up. Right, so that Wolfram guy is always talking about cellular automaton and computation and all this kind of crap, but this, this is a big thing with him, this idea of creating systems that have very simple rules, and then you find that complexity precipitates out of those little simple rules. And I mean, this explanation for charge is so simple and the rules are so simple. I mean, I should be able to get him interested if he'll just pay a tiny bit of attention. Because, you have 2 plus 2 plus 2, right? I mean, it's 2 plus 2 plus 3. 2 kinds of force, 2 kinds of matter, and 3 kinds of interactions, and you duplicate charge. I mean, an elemental, fundamental part of physics. But see, you just can't get anybody interested. They won't pay any attention because they think everybody is a crank, and they think everybody who has an alternative theory is wrong. And unfortunately, he has a unification type theory, a theory of everything that's just absolute convoluted crap. I mean, it's got all of the physics bullshit in it, all of the entanglement, the wave function, all of that woo. And so hopelessly messy and complicated. Now, it's not going to be anything like an explanation of how the real physical universe works. Alright, so anyway, that's where we are, and it's just very depressing and such. So I will work on the push and gravity pages. Uh, yeah, there's just not that much to say on those subjects. It just seems like people just don't want to pay any attention to the fact that it does work. And the problems are, nobody has even tried to solve any of the problems that might exist. They haven't even tried to see if they have some explanation. Nothing. They just assume it can't be solved because they don't want this answer. They don't want the simple answer. Clearly. All right. Till the next time and such and so forth and whatnot. Stupiverse. It's just so. I don't know. Like I said, I assume eventually you're going to have to, find the truth and accept it, and it's just going to be, like I said, it's. You can only be embarrassed for the human race that, they obviously just didn't want to hear the truth. All right. Till the next time.